Hello, geometry students. This is Mrs. Turner. I'm very happy to be giving you your second online lesson. This lesson is on radicals. The last one we did was on Pythagorean theorem. So go ahead and as before, all you need is a piece of paper and a pencil or a pen just to write these notes down on. So you're going to write at the top of your paper just the word radicals. And as I go through this video, feel free to zoom in, pause, write down questions, and as those questions come up, you can ask them during our Zoom session. So the reason we're talking about radicals is they do come up quite a bit in geometry, especially in the context of right triangles, which is what we talked about in our last lesson. So let's go ahead and look at a problem that might be somewhat familiar to you, the square root of 9. Now, there's a bunch of different kinds of radicals, but the ones that we're going to talk about in this class are just square roots. So square root and radical for the purposes of this lesson are pretty much the same thing. So I can either say square root of 9 or I can say radical 9. Can you figure out what the square root of 9 is based on maybe what you learned before? Some of you might be saying, well, I know square root of 9 means what number do I multiply by itself to make 9? And the answer is 3. That's correct. Good job. Let's try another example. Example number 2. Square root of 4. Of course, you can do this on your calculator, but if you had to do it in your head, how would you do the square root of 4? You ask yourself, what number do I multiply by itself to make 4? Notice there's a pair of 2's. So since there's a pair of 2's, my answer is just 2. Now, these problems are both what's called perfect squares. What that means is after we solve them, the answer doesn't have a radical left in it. So, unfortunately, many of the problems that we work with in here are not going to be perfect squares. Our answer will still have a radical in it. So I'm going to show you how to do those problems, but the steps are exactly the same. Let's write down the 2 steps that we already know that we need to do. The first step is something called to factor. Now, factor sounds fancy, but all it really means is to rewrite as multiplication. So we rewrote 9 as 3 times 3, and we rewrote 4 as 2 times 2. And we're going to do the same thing with all of these problems. The second thing we did is we looked for pairs. So when we see a pair, we pull out any pairs. Since we had a pair of 3's here, we took that out and our answer was just 3. Since we had a pair of 2's here, we took that out and our answer was 2. So let's see, for example, number 3, if I want to do the square root of 12, I'm going to do exactly the same 2 steps. First, I want to factor. Can you try factoring 12 for me on your paper? 12 can be written as 2 times 6, which can be written, 6 can be written as 2 times 3. So when we factor 12, we can write it as 2 times 2 times 3. So we did step 1, factor. Now we want to do step 2, pull out that pair of 2's. Notice that there's only one 3, so it has to stay inside the radical, and that is considered to be our final answer, 2 times the square root of 3. Now we could turn that into a decimal on our calculator if we wanted to, but this is considered to be the exact answer. And it's also the format that the answers on your SAT exam will be in. So this is good for us to be learning. All right, let's do another similar one to that. Let's do square root of 18. Again, the same 2 steps, we want to factor. 18 is 2 times 9, and 9 is 3 times 3. So when I factor 18, I can write it as 2 times 3 times 3. Can you figure out what we would do next? We would take that pair of 3's and bring it out, and now I have 3 radical 2, and that's my final answer. Now, sometimes, this is like the vast majority of the problems on the worksheet are going to have this kind of a component to it. But sometimes, let's do, for example, 5. You might have something that already has a number outside the radical, even in the beginning of the problem, like 5 times the square root of 8. We still follow the same 2 steps. We're going to factor the 8. 8 is 2 times 4, and 4 is 2 times 2. So I keep the 5 there, and I factor the 8. Now, I've done step 1, factor. Now I want to pull out pairs. So I'm going to pull out this pair of 2's. Now, the key here is what to do with that number when you take it out, because there's already a number there. Can you guess what you do? Some of you are probably thinking, do I add or multiply? The answer is multiply. So I'm going to take 5 times 2, because of the 2 I brought out and the 5 that was already there, and keep a 2 inside. And my final answer is 10 radical 2. So that's what the vast majority of your problems will look like. However, there are 3 other rules that we can use to solve slightly more complicated problems, but these are really not that bad. So I'm going to tell you these 3 rules. I'm going to do one example of each, and then our notes will be done. So it's not going to be that painful today. And again, like I said, we can answer any questions during the Zoom session. So the first rule that I want to tell you about is something called the product rule. And product, as you may know, is just a fancy name for multiply. So it's like a multiplication rule. And what it basically tells us is if we have the product of 2 radicals, so for example, square root of a times the square root of b, we can put them together underneath the same square root sign. So if I have, for example, the square root of 2 times the square root of 8, it becomes the square root of 16. Now we could solve this by factoring, but both of us all of us know that 16 is just 4 times 4. So the answer here, you can think of this as a pair of 4s. Now, if that bothers you because we didn't factor all the way, you could, if you wanted, factor this completely. So that would be another way of handling it. And you could see that you had 4 2's on the inside. So we'd have 2 pairs here. We would take both of them out and multiply them and still get the same answer. So it's kind of up to you, how detailed you want to get when you get to that part of the problem. But the basic concept here is that we can put the 2 and the 8 together multiplied underneath the same radical sign. So that's called the product rule. And by the way, you can also read this rule from right to left, although I don't believe any of our homework problems will require us to do that. Now, there's another rule that we want to look at called the quotient rule. And many of you probably know that quotient means divide. So let's write quotient rule on the board. And then let's do an example, a general example. So again, we're talking about a fraction or a division problem inside the radical. The quotient rule just tells us that we can break that into 2 pieces. So if I have the square root of a over b, I can rewrite that as the square root of a over the square root of b. So for example, let's say that this example here was example 6, and we'll make this one be example 7. If I wanted to do the square root of 9 over 4, I can break this apart into 2 pieces as the square root of 9 over the square root of 4. And we know from the beginning of our notes that the answer to the numerator is 3, and when we simplify the denominator, we get 2. So that's an example of using a quotient rule. Just like with a product rule, we can read it from right to left, but I believe all of our homework problems have us read it this way. So that's why I gave you the example I did. All right, one last rule I want to talk about is something called rationalize the denominator. And this will be our last example. Don't worry if your spelling's perfect. Like I said, if you need to zoom in, go ahead. We'll call this one example 8. But rationalize the denominator is something that you need to do when you have a problem that you're supposed to simplify and there's a radical sign on the bottom. We're not allowed to leave that there. So even though you think to yourself, well, there's nothing to factor, there's no pairs to pull out, we're still not done because that radical's on the bottom. So we rationalize the denominator to get rid of it. And the way that we do that is we multiply the top and bottom of that fraction by whatever was in the denominator. Can anyone guess what this is? Square root of 5 over square root of 5? What does that, just that part of the problem, what do you think that's equivalent to? Some of you may have said, hey, any number divided by itself is 1. That's just the same as 1. So we're not really changing the value of this problem. We're just changing the formatting of it. Then when we multiply across the top and bottom, we get 4 times radical 5 on the top And using the product rule, we can put both 5's in the same radical on the bottom. Notice we do have a pair now. So the top is still 4 radical 5, but the bottom becomes 5. And this is considered to be our final answer. Now, some of you might be saying, hey, that looks a lot more complicated than what we started with. It does have more numbers in it, but this is considered to be the correct answer. So anyway, I hope that answered some of your questions, but I do know that you probably will have more, and I'm looking forward to helping you during Zoom. Thanks, guys. Bye.